Stellite is a range of cobalt-chromium alloys designed for wear resistance. The alloys may also contain tungsten or molybdenum and a small but important amount of carbon. Stellite alloys are composed of various amounts of cobalt, nickel, iron, aluminium, boron, carbon, chromium, manganese, molybdenum, phosphorus, sulfur, silicon, and titanium, in various proportions. Most alloys contain 4 to 6 of these elements. Stellite is a family of completely non-magnetic and corrosion-resistant cobalt alloys of various compositions that have been optimized for different uses. The alloy currently most suited for cutting tools, for example, is Stellite 100, because this alloy is quite hard, maintains a good cutting edge at high temperature, and resists hardening and annealing. Other alloys are formulated to maximize combinations of wear resistance, corrosion resistance, or ability to withstand extreme temperatures. Stellite alloys display outstanding hardness and toughness, and are also usually very resistant to corrosion. Typically, a stellite part is precisely cast so that only minimal machining is necessary. Stellite is more often machined by grinding, rather than by cutting. The alloys also tend to have extremely high melting points due to the cobalt and chromium content. Typical applications include saw teeth, hard facing, and acid-resistant machine parts. Stellite was a major improvement in the production of poppet valves and valve seats for the valves, particularly exhaust valves, of internal combustion engines. By reducing their erosion from hot gases, the interval between maintenance and regrinding of their seats was dramatically lengthened. The first third of the M2HB machine gun and M60 machine gun barrels, starting from the chamber, are lined with stellite. The locking lugs and shoulders of Titanii rifles were also made of stellite. In the early 1980s, experiments were done in the United Kingdom to make artificial hip joints and other bone replacements out of precision-cast stellite alloys. It is also widely used for making the cast structure of dental prostheses. Stellite has also been used in the manufacture of turning tools for lathes. With the introduction and improvements in tip tools, it is not used as often, but it was found to have superior cutting properties compared to the early carbon steel tools and even some high-speed steel tools, especially against difficult materials such as stainless steel. Care was needed in grinding the blanks, and these were marked at one end to show the correct orientation, without which the cutting edge could chip prematurely. While stellite remains the material of choice for certain internal parts in industrial process valves, valve seat hard facing, its use has been discouraged in nuclear power plants. In piping that can communicate with the reactor, tiny amounts of stellite would be released into the process fluid and eventually enter the reactor. There the cobalt would be activated by the neutron flux in the reactor and become cobalt-60, a radioisotope with a 5-year half-life that releases very energetic gamma rays. This phenomenon is more problematic in boiling water reactor (BWR) plants, since the steam is in direct contact with both the reactor and the steam turbine. Pressurized water reactor (PWR) designs are less susceptible. While not a hazard to the general public, about a third to a half of nuclear worker exposures could be traced to the use of stellite and to trace amounts of cobalt in stainless steels. Replacements for stellite have been developed by the industry, such as the Electric Power Research Institute's NOREM, that provide acceptable performance without cobalt. Since the United States nuclear power industry has begun to replace the stellite valve seat hard facing in the late 1970s and to tighten specifications of cobalt in stainless steels, worker exposures due to cobalt-60 have dropped significantly. Stellite was also used as the cage material for the first commercially available artificial heart valve, the STARR, EDWARDS caged ball valve, first implanted in 1960.